All right. So hello also from my side. My name is Philipp. I am a front-end engineer at commercetools. You can find me on Twitter under the Twitter handle Philipp Sporrer. And I want to talk to you today about testing and more specifically test-driven development in React. And as most of you in this audience, I think, I'm a big fan of React and I love React. And React really changed the way that we develop applications, especially in the front end, may it be like native or for the web. It really changed the way we develop applications. And there are a lot of reasons to be a big fan of React. And one of them is baked right into React Core, because React Core is decoupled from the rendering. So React Core doesn't know anything about the DOM, about native, about VR, or about any renderer that might be there in the future. And a little side note, with React 16, you're actually able to write your own custom renderers. So why is that important? Why is that good? Because the code that we write, the JavaScript code that we write, it goes right in React Core. So the JavaScript code that we write, it's also independent of the DOM, of native, and of VR. And that means that also the tests that we write, they are independent of these renderers. And this is a good thing because this makes testing a lot easier and a lot faster. So if we think about it a bit, where do we actually come from when it comes to testing in the front end? If you think back a couple of years, you might recognize some of these libraries. I remember myself back in the day working with YUI. A lot of you, and I guess everybody knows jQuery, also Backbone. And when using these libraries and when wanting to write tests, there weren't that many options, and you were always depending on some kind of browser environment to be set up to run your tests. So some tools that we use for testing, of course, Selenium. Everybody loves it, of course, I know that. And also Phantom.js. And yeah, so the bottom line is that you always require a browser in order to run your tests. And needing access to the DOM is actually what slows down your tests. Why? Well, because if you want to run your tests, you first of all need to spin up a browser, which is slow already. Then you need to run your test against this real browser, maybe make some network requests, which are also slow. Then you need to shut down that browser, maybe spin it back up for the next test. So this really slows tests down. And we don't have this anymore with React because, as I said, React is decoupled from rendering. So you don't need to spin up a real browser anymore to run your tests because you're just testing normal JavaScript, right? You're not testing any browser-specific stuff. And that's why React enables us to write fast and robust tests very easily. And this is a big win because for us as developers, one of the biggest reasons why we skip writing tests is when they are hard to write and slow to run. And React addresses both of these problems at once. React makes it really easy to write tests and also really fast. And that's why it enables us to finally to do test-driven development for our front ends. We've been able to do this for JavaScript, for Node.js, for our backend code, maybe for CLIs for a long time already. This is really cool to do test-driven development there. But finally, we're also able to do this in the front end, and React is a big reason why we are able to do that. But to put all of this in a bit more context and to actually show you like how I got into test-driven development with React, I want to talk to you about the company that I joined a bit over a year ago in December 2015. It's called commercetools. For those of you who don't know it, the product that commercetools builds is a cloud-based commerce platform. And what that means is that we provide services or just an API in the core that helps you build your online shop. And we provide services for your products, for your, like to manage your products, your categories, your discounts, your prices, customers, cards, orders, and so on and so forth. And this can get quite complex. And because it can get quite complex to manage all of this, we also provide a UI to manage your online store. And this is actually what the team that I'm working on is building right now. We call it the Merchant Center, because that's the place where merchants, the people who conduct online business, go to every day to conduct their daily work. And for us, it's really important to make sure that the code that we ship to production actually works. Because the people that use our software, they don't use it for 10 minutes a day. They use it for hours and hours every day, every single day. And that's why we need to make sure that the stuff that we ship, it really works and it doesn't slow them down, because otherwise they might lose money. So when I joined the team, which is close to a year now, the team was already writing tests in React. And this is what a lot of people are actually doing, because as I said, it's quite easy to do that. But what we didn't do, and this is what a lot of people also don't do, is that we didn't write the tests first. And this is even the case if we look a couple of months back, and this is including myself. So also I wasn't writing the tests first if I look a couple of months back. So what happened? What changed? What made me and the team consider doing test-driven development to write the tests actually before you write the implementation? Isn't that really like a bad idea in the first place? And to understand what my motivation was to do it, I want to tell you a little story. So I was working on a user story and some feature for the Merchant Center, and I was really excited about it. I was really looking forward to working on it. And then I sat down and I worked on it for, I don't know, 2, 3, 4 days, produced a lot of code, like a couple of thousand lines of code, like 2,000 lines of code. And I was really happy with it. I was really pumped. I wanted to show my colleagues what I did. I went to GitHub, I created the pull request, added some nice description for the pull request for the people to review it. And then I hit the submit pull request button. And all I was expecting was thumbs ups and hearts and party poppers and of course approvals. But all I got was this: tests are missing. And my reaction was this, because that meant for me that I have to go back to my code and write tests for like 2 or 3 hours in a row, just writing tests, which is really boring. It's really exhausting and it's not fun. And the problem with that is that the quality of the tests really suffer if you have to do that, if you write the tests after you write the implementation. Why is that? Why does the quality suffer? Now, there are 2 reasons for that. Reason number 1 is that you will simply forget to add some tests. You will not cover every single case in your component. Because if the code that you wrote is already 3 days old, then you won't remember everything that you thought about that moment when you wrote that code. So you will just forget tests. There's no way you remember every single case. Now this can be addressed a bit if you have like a strict code coverage in place, a test coverage. And I actually tried this out in one of my projects because I didn't want to do test driven. I just, okay, let's just add some coverage and I won't forget any tests anymore. Well, yeah, you don't forget any tests, but having a strict coverage in place is really annoying because in some parts of your application, you have code that you don't want to and don't need to test. Think of like a configuration object that just contains some static logic, or not even logic, it's just static stuff. And your code coverage will tell you, well, you can't merge your pull request because these lines are not covered by your tests. So you need to add a test that's really stupid that just compares two objects with each other that are actually the same, and it's obvious that they're the same. So it's really annoying and it just slows you down in the end. So I thought that this is not the right solution. And there's actually a second problem if you don't write the test first, which is that the code is less testable. And if the code is less testable, that means that the tests are harder to write. And as we already talked about earlier, if the tests are harder to write, we as developers, we tend to skip them because it's hard to write. And I was not happy with this situation because this means that the code that you ship to production, you can't be confident in that code because you know that you probably didn't cover every case, you didn't test every case. And this is a problem, like not being confident in your code is the worst thing that can happen to you as a developer. And at that time, I was already reading a bunch of articles. I had already heard about the term test-driven development, but I didn't really believe in it. I didn't really think that it's a good thing to do until I read an article by Eric Elliott. I guess most of you, or maybe some of you, know him. And from that article, I want to show you 2 quotes that I think really stand out. The first one is this: studies from Microsoft Research, IBM, and Springer tested the efficiency of test first versus test after methodologies and consistently found that a test first process produces better results than adding tests later. And to make that argument even stronger, he also says that writing the tests first leads to 40 to 80% fewer bugs in production. And that's a big number. That's a really big number. And I was really wowed by that number. And by the way, this number is backed up by real evidence. He didn't just make this up. And for me personally, it's not only about this number. I mean, this is great for the business. Yes, we have less bugs in production, but why is it good for me as a developer? And for me, it was just really about being more, as I said, having more self-trust in the code that we write. And Now this sounds good and all, but how does it actually work? How can you do test-driven development for your React components? And I started doing it. I just said, okay, screw it. I'm just going to try it out together with one of my colleagues. We really just pioneered in that space in our team. And we learned a lot in that process. We made a lot of mistakes. And I'm here to show you like what the process is that we follow right now when we do test-driven development. And this is really similar to the standard way of doing test-driven development. So the step one when doing test-driven development is called describe it. So the first thing you do is that you think about what you are about to build. In this case, we're building a button component, like a simple button component that shows a label and you can click it and it calls some function when it's clicked. And as you see here, we just describe this test. It's just some text, and it's actually also called README driven development, RDD, because this just reads like a README, right? This could be the README of my component. If you remove the describes and the its, you know what it does, you know the interaction of the component. So let's walk through this a bit. So first of all, we have two blocks here, and the first block is the rendering. So we describe exactly what's rendered inside of our component. First, it should render a touchable opacity React Native element. This is what you use to make something clickable in React Native. Then it should render a label, and then it has types. So a button, you all know, a button can have several types. In this case, if the button has no type or if you didn't provide any type specifically, then it just has the default style. If you say this is my primary button, then it should have the primary style. We also have a second block for interaction. And since it's just a button, you can just click it, and when it's clicked, it should call the onClick callback. So much for step one. And something to note here is that we didn't actually write any test yet. No test. We just described what we're about to build. And this is also important because if you would write all of the tests up front, you would really hinder your exploration process. You would hinder your creativity when writing code. And this is not how successful test-driven development works. The next step is then, the next step is to really start testing. And the first test that we want to write is for our touchable opacity element. And this is how it looks like. So in the top here, we create a new React component, which is the button component that we want to test, obviously. And we don't add anything yet. We just return null. So it's just a component that renders nothing. It doesn't do anything. But we do this, we create this component just so that we have something to test against. Because if you write your test first and you were to import the button in this line, it would just crash because there's nothing to import. So we just create the button component so that we have something to import. And then we write our first test. So we say we render the button, and then we expect that in this rendered output, we want to find this touchable opacity React element. And we expect there is exactly one of these elements in our component rendered. And the really important thing here is to really watch this thing fail. So right now, if you run your test runner, in our case, we're using Jest, you will see this output. It just fails the test. And you see that we expected to have exactly one touchable opacity element, but we received 0. So why is that important? Why do we want to watch the test fail? Because there are tests that are false positives tests. What does it mean? It means that the test says that it passes, so it's green, but actually it doesn't work. So the test actually doesn't pass. And I also like to call these tests Volkswagen tests. Some of you may know why. And I actually discovered one of these when I joined commercetools pretty early on. And I found like a file with like 60, 70 assertions, and 90% of these assertions, they said they were passing, so all of the tests were passing. But when I looked at the code, I found out that actually most of them were not passing. And how can this happen? In this case, it was all asynchronous tests. So in each test case, there was some asynchronous process triggered, like fetch some data from some server. And then when the data comes back, we do some testing. Like we check if the object that is returned is equal to foobar or something. But all of these tests, they didn't wait until the data came back. They just said, okay, I'm done, without waiting for the data to get back. So they all said, okay, I'm working, I'm all good. They are all green, but essentially everything was just broken. And that's why you want to avoid these kind of tests. And that's why you want to watch the test fail before you make it work, which is actually the next step, making it green, making it work. For this test, it's really, really simple. we just don't return null anymore. We return the touchable opacity component from this button, and then the test is green. We see the output, okay, everything is fine, everything is passed. All right, so much for a bit of theory of how the test-driven development can actually, like how the steps are of test-driven development. Now I want to jump into some live demo, some risky move, but we're just gonna try it anyways. So let's do this. I think I can do it a bit bigger here, like this, and this also. Is that fine to read for everybody, also in the back? Yeah, okay, cool. Okay, so this is exactly where we left off. On the right side, we see our test for the touchable opacity component, and on the left side, we see that this test is actually passing. And again, we look at the README that we just wrote. We say, okay, the next test that we need to write now is it should render a label. And this is actually fairly straightforward. But before we test anything here, we need to give our button some label so that it can display this label. So we say button label equals like submit. So we render like a submit button here. And then in this test, we say expect wrapper.find. And whenever you want to render some kind of text in React Native, you need to wrap it inside a text React element. So that's why we search for this text element. And then we check if this text contains our submit label that we put in to the React component. Let me just say this should be true. If we render this, we see our test is failing, and this is good. We see, okay, we're not producing any Volkswagen tests right here. So let's just open the button component now. And now we just write the implementation. We make the test green again. So now we render this text element. We import it from React Native, and we say inside of here, we render the label that gets passed into this component via the props. Now, if we hit save, on the left side, we see, okay, our test is passing, everything is fine. And the fourth step when doing test-driven development, I didn't mention this earlier, is that you do a refactor, but this step is optional. So we look at our code and we see, okay, is there something that we need to improve? Is there something that we missed maybe? And there actually is, because we didn't specify what type this label should have. So we say button prop types is, should be a label, and the label should be a string, and it is required because it doesn't make sense to render a button without a label. Prop types. All right, test should still work. Yes, it does. This is great. All right, let's go back to our test. We now have a test for the label. Next up, we're looking at the type. So in this test, we're not actually giving the button any type. We're not saying you're a primary button. We're just saying you're a some button, normal button, like a default button. And to do that, we don't pass it any specific type. So that's why we don't change our rendering up here, because we say when we don't pass any type, it should render the default style. So we can directly go to our test and say, all right, we expect again to find this touchable opacity component. And we expect that this has a prop called style. This is what you use in React Native to style. And this should be equal to some other thing that is styles.default. Now this styles object, it's not defined yet. Where does it come from? Of course, it comes from the button component. So we expect that the button component exports its styles so that we can use it for testing. We don't use it in any other component. We just use it for testing. So if we run this test now, we should see it fail. Yes, we do. And we actually see that cannot read property default of undefined. Yes, because this styles object, it's not exported by the button yet. So this is the first thing that we do now. We go export const styles. And this is a style sheet.create. And then we need to import style sheet also from React Native. We pass some default style and we say background color is papaya whip. All right, it's a nice color, by the way. So we have our style sheet now. If we hit save, the test should fail. Yeah, because we have a typo here. Now, whoops, cancel, save. Right. Now the test is failing because we expected that the style is equal to this object, background color papaya whip, but actually it doesn't have a style yet. So let's add the style. We say style equals to styles.default, hit save, and our test should be green again. Yes, it is. Nice. All right, do we need to refactor anything? I don't think so. So we can directly go back to the tests and continue with the next one. Now this one again is regarding the type, but in this case, we're actually explicitly passing our button component the primary type. So we need to change our render in this case. And to do that, we just copy this before each block and say every wrapper inside of this describe block should have these props. So not only should it have the label, but it should also have the type called primary. And then when we test the component, we do exactly the same thing as we did for the previous test, except for the styles, which should not be default anymore. It should be the primary style. So we just say styles.primary, we hit save, and we see our test fail. Because since the style is not defined, we're right now expecting the style to be undefined, but the style is still the default style, which is background color is papaya whip. So we go back to the button component, we add our primary style, which is, let's say, pink. And now we need to accept a new prop called type. So we go here, we say, all right, we have a new prop, it's called type. No. Prop types, and it should be one of the following values. One of. It can either be default, or it can be primary, which is the one that we're passing in for this test right now. And this default type, we don't want to explicitly tell the button that it should be default. We just want, okay, if I don't say any type, I want you to have the default style. So what we do here is that we say, okay, you have a default prop, default props for your type, and this is default. So whenever we don't specify a type, it's going to be the default style. And now we can use this type prop by just dynamically using a style. So we say props.type here. And again, if there's no type provided, the type will be default. So this is essentially the same what we just had. It is then styles.default. But if the type is primary, this will be styles.primary. And now if we hit save, our test is green again, which is great. So now we have a default style and a primary style. All right, so much for rendering. Now let's get into a bit more interesting stuff, which is the interaction. As I said, when we click the button, it should call the on-click callback, pretty standard stuff. We also need some setup code here. So again, we need to render our button somehow. In this case, we also need to pass it this on-click handler so that it can actually call it. And in this case, if I just write this code here, I couldn't refer to it down here. So what we instead do is that we don't add this the props hard-coded to the button here. We create a new object that we can use throughout our tests. We just call it props. And before each test, we reinitialize this object so that we have like a clean state for each test. And we say we pass a label as a prop again, the submit that we just had. And we also pass a on-click prop, which is just a jest function. And this jest function is just a spy, like most of you know this from other testing frameworks, which is just a wrapper around a normal JavaScript function that lets us inspect how often this function was called. And so in this other describe block here, for clicking the button, we want to make sure that the button is actually clicked before each of the its in this describe block. So we have another before each, where we again search for the touchable opacity component, which we use for clicking the button. So we say find touchable opacity, and we pick the onPress prop, which is the default API from touchable opacity, and whatever function is in there, we just execute it, we just call it. And then in our test, we expect that the onClick function that we pass into the component was called. So we say expect props.onClick to have been called times 1. And this to have been called times, we can do that because this onClick function is a jest function, which is a spy, so we can check how often it was called, with which arguments it was called, and so on. So if we run our tests, we should see it fail on the left side again, hopefully, if it executes. Yes, there we go. Okay, it fails. And right now it's saying that the prop that we picked, which is the onPress prop, is not a function. And the reason is because it's just not defined yet. We see this touchable opacity, it doesn't have this onPress prop. So let's just add it and say onPress is, for the moment, just an empty function. If we run our tests again, we see just an action. We see that just says, we expected the function to have been called one time, but it wasn't called at all right now. So let's change that. So we go back to our button component, and we don't pass in just an empty function anymore. We pass in the onClick function that was passed to this component via the props. And if we hit save now, we still don't see our test passing because I messed something up probably.
You haven't passed the props into the component.
Ah, true. Yeah, thank you. Good catch. We need to, of course, pass the props into the component. We do this, thank you very much, by just spreading them into the component here, and then we see the test fails. You just saved me. Yeah, one more thing we can do, step 4, is refactoring. So we also specify the prop type for this onClick function. We say onClick is prop types.function, and it is required. And if we do that, we will actually see that we get a warning once the tests decide to rerun. Yes, we get a warning that the onClick prop is marked as required, but its value is undefined. And that is because for the other tests that we wrote up here, we didn't specify this onClick function. So what we can do is that we pass this manually up here also. Like this, it's just an empty function because we don't care if it's called or not. We do the same thing down here. This is fine for our simple use case, for our simple test right now, but I don't encourage you to do this when you write your test for your components. What you can do instead is that you create a new function up here that you call like create test props. And you use this function every time you render this button. And this component, then it just returns an object, which you can like spread into your component again. And here you just define the props that you will always need in this component, which is like the onClick and also the label of something. And then you can call this function, like you could call it here, instead of passing this props in manually, and then spread these props inside here. All right, so much for the live demo. Let's get back to the presentation. And I need to set up down here as well. So from here on, it's always the same procedure. So you still remember the 4 steps, right? We had the describe it in the very beginning, and then we had this infinite loop basically of developing the button component. We first of all made the test fail, we then made it work again, and afterwards we did some refactoring, and then we went back to making the next test fail. This is the procedure, and this is always the same, right? This is like also very simple to remember every time. So the question now is, did this actually pay off? Did doing test-driven development, did it pay off? And I sadly don't have like these huge numbers as we have seen in the beginning from the blog post, just because not the whole team switched to test-driven development and we didn't really track anything. I just like wanted to try it out for myself. And what I can tell, and this is true for also other developers in the team, is that the frustration of writing tests went down dramatically, because you don't have to sit down for hours to write tests. You write them gradually when you develop your components. And also now when I open up a pull request, the likelihood that I will get a response like this is much higher now. And now you can also do it. You can also go ahead, go to work tomorrow and start doing test-driven development for your React components. It's really easy, you just saw it. You just need to get into this process, into this habit a little bit. But you might get stuck along the way, because there are some parts of React when testing, it's really not that trivial how you will do that, like some special cases like function as a child components, higher order components, stuff like that. But we got you covered because my colleague Nicola, he's in the audience, the big Italian guy, he just published a blog post, testing in React, best practices, tips and tricks. And this just shares what we as a team have learned when writing a lot of tests with React and doing a lot of wrong things and then figuring out how to actually do it right. So there's a lot of valuable tips in there. Also, we linked some other blog posts in there. So this is a good place if you get stuck when writing tests. And it is published in our tech blog, in the company tech blog. It's called techblog.commercetools.com. And on that site, it's going to be the first blog post that you see there. And if you like the content that you see there, and maybe also this talk, you can also join us. This is only part of the team. We're hiring, of course, as everybody else in this city is. And yeah, we'll be happy to talk to you. But as it was teased already in an email before this meetup, there's one more thing. And it is the GraphQL Europe conference. And since the company that I work at is a sponsor of this conference, we have a 50% discount that we want to give away. This link that you see here, it will link you to a Google form where you can enter your name and your email. And then whoever wins will be contacted directly by us, and you will get this discount for the conference. It will take place in May 21st in Berlin. It's going to be awesome. Some of the co-creators of GraphQL will be there. Amazing talks. It's a Sunday, I think. So yeah, good things coming up. And that's it. And I think we have a couple of minutes for questions.
Two questions. First, when you write the test, you explicitly remap on press with on click.
Yeah.
Is there a reason for that?
What would you do instead?
I would say just on press.
Yeah, so for us, it's kind of a standard to use on click and not on press, because in the web, it's always on press. But I guess if you're just in the React Native environment, you could definitely just use on press. So there's no specific reason, no. Yeah.
Okay, the second question is that have you tried Flow actually to reduce some part of the test?
We didn't try Flow in the product that we're building yet. We have some other like notes scripts where we tried Flow. The thing is, we have like, I don't know, tens of thousands of lines of code right now. Yeah, we could introduce Flow gradually. Currently, we're a team of 8 developers. So it would be quite a big step to say, okay, right now we're doing Flow. And we have a lot of refactorings going on. One of them was actually Jest. So to migrate the whole code base to Jest, which is still ongoing, it took like 2 months because like we don't have the time to do this for 1 week straight. So Flow is definitely great. It would reduce some boilerplate code. If you can use it, feel free to use it. And I would love to use it, of course. So if we have time for another refactoring, we might consider doing Flow. Yeah. Yeah.
Yeah. Cool. Looks awesome.
Thank you.
One question that I had: have you looked into Jest snapshot testing?
I have. So if you read the blog post, we actually share our opinion on snapshot testing. And maybe to take a bit away from the blog post already, of course, read more. We don't believe that solely using snapshot testing is the right way, because it only gives you part of the information about your component. So it's valuable to have this README, quote unquote, of your component that's like in form of a test, because it explicitly says what's important to be rendered inside of this component. So that's why we say a combination of both is the best way to go, because you want to, on the one side, validate the structure of your component, which snapshot testing is really good for, and you want to see if something changed. But on the other side, you want to be able to do test-driven development, which you're not able anymore when using snapshot testing. And you want to really have a description of what's important inside of this component. But for a lot of like simple use cases, snapshot testing is sufficient. Yeah. Sure. Any more questions? Feel free. We have time.
I'm gonna try TDD tomorrow. First, I have to write old places.
Okay, then thank you very much for listening and see you.